And what is the really exciting, unique way that you could die on Neptune?
Probably of boredom. But if boredom doesn't...
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 86. We are in our deadly solar system unit. And Cheryl, I think we've come almost to the end of our deadly solar system.
Yeah, because Pluto doesn't exist anymore. I mean, Pluto exists.
Well, it definitely still exists. It's still there. It hasn't gone anywhere.
Oh my gosh. Pluto as a planet. The planet of Pluto does not exist anymore. Could I say that? Kind of. That's more of an English question than a science question.
Yeah.
So we don't need to get into that here. But Pluto's not a planet anymore. So we're just like creeping up on the outskirts, huh?
We are. Do we want to do a quick summary to see if you can remember the order to get us to where we are?
My very energetic mother something 9 noodles. Nope. It was 9 pizzas.
But you know what the planets are?
Yeah. Oh, that's probably more important, huh? So Mercury, Venus, Earth, Mars, Jupiter, Saturn. And then there's Uranus and Neptune. So 9 pizzas. Nope. Pizzas is Pluto. Still not helpful. Uranus, Neptune, because very cool.
Yep.
Us is you. Okay, got it.
You've been saying it. You just didn't register it.
Yep, those are 8 planets.
There you go. And I think today we're going to talk about Uranus and Neptune together, if that's okay.
Yeah, that sounds great. I actually do know something about Uranus, Brian.
Oh, do you, Cheryl?
Did you know
what
that
do
it's
you know?
a gas planet? That was
you said that
I would say to people in elementary school because it was hilarious. We used to say it's one of the largest gas planets, but I now know that that's not true unless you call all of them large gas planets.
Also true. Yep. First time I heard that joke was when I saw the movie E.T.
That joke's in E.T.?
And I did not understand what it meant when I saw it in E.T. And my mom had to explain it to me.
Oh. That's funny. Oh my gosh. Yeah. Oh, kids. Yeah. I was just like, why is there even a planet called Uranus? So,
well, funny you should ask, Cheryl. Would you like a little random story about the name of that planet?
Yeah, I actually would.
So first of all, I usually call it Uranus. 1, because that's the way I learned it. And 2, because it gets less Snickers. Although if you think about it, Uranus is still not that much better.
It's a lose-lose situation.
It really is. It really is. And if you want to go back to sort of like the Latin, it's probably more like Uranus or something more fun like that.
That's
isn't that
very
fun?
Cool.
But I always find this incredibly funny. The original name of the planet when it was discovered, the original name of the planet was George.
What?
Now, I'm using a little bit of exaggeration here. It was technically, the original name was George's star, but still, I'm like, it was the planet George. They named it after King George.
Oh my gosh, you're kidding me. I mean, that's also like not surprising.
Right.
I was like, that was the king's one. It's his.
Yep.
Oh my
so,
goodness.
But it didn't stick. But I just think it's really, really funny. So when people are like, well, is it Uranus or Uranus or Uranus or whatever? It's like, well, we'll just call it George.
I love that. That's really funny. Oh my goodness. That's it. I mean, it is kind of a fun one when there's all these like fun ones that are like gods. And then there's George. There he is.
Planet George.
But I will tell you that's about the start and end to my knowledge on Uranus or Neptune.
Okay.
So we have some gaps to fill in.
All righty.
Yeah.
Well, we'll do a pre-assessment, but it may be more of you asking questions than me asking questions.
Okay, that sounds good.
But let's go ahead. First of all, what do you picture when you think of Uranus and Neptune? What do you think they look like?
Blue and purple. Just like cool colors.
Both of them are blue and purple, or one is blue and one is purple?
Or maybe one is one and one's the other.
Okay.
I don't know if those are accurate because most of my color guesses have not been, but that's what I pictured. I know that they are much smaller than the gas giants. Like I think they're like a lot smaller, like maybe smaller than our planet.
Okay.
But I'm not sure on that totally, but they're definitely not gas giants.
So if you had to guess, do you think they're like half the size of Jupiter or Saturn, or a quarter of the size? You said they might be smaller than Earth. Like where comparatively would you guess the size of them? And you think they're both similarly sized, or do you think one of them is bigger or smaller? Or
I think they are, gosh, I would say like compared to the really big ones, they're pretty similarly sized. But I don't know how much that means compared to how big the big ones are, But I do remember that when Pluto was a planet, it was the smallest planet.
Okay.
Now it makes sense that it got bumped off the list and everything. Now that many, many lessons ago, you told me more about why that was the case. But when I picture the little styrofoam diagrams, I feel like I picture Uranus and Neptune I think Neptune and Pluto are similar sizes. I think Uranus is bigger. That's like kind of what I'm picturing is it kind of like tapers out on the end. But as far as like compared to anything, I'm going to guess that, let's see. Wait, no. Which one's on the end? Uranus is on the end. I think that's the smaller one. I think it gets smaller and smaller. No, Uranus is not on the end. Noodles are on the end. Neptune's on the end. That's okay. Man, they just like, they're kind of like these little twins in my mind. So then picturing any difference between them is like, I know the same amount of things about them and that they're way out there.
Yeah.
And that they're gas planets and that they're smaller than Jupiter.
Okay.
And so I don't know, like distinguishing things between them or anything like that. I just keep picturing that Futurama episode on Neptune, where that's where Santa lives and his elves are like these little like Neptune guys.
Oh gosh, I'm sure I've seen it. I vaguely
Santa's
remember.
evil. He's a big like robot.
Okay. Yep.
And they're like abused, like they're just small because they're malnourished. But they look like these like cute little cool toned skin aliens. They're very cute. And that's what I picture.
That's what you picture for Neptune. That makes sense. That makes sense.
Is that Futurama episode? Yeah. Yeah.
Okay. Great. What else do you think might be going on with the planets? Do you think they have any moons?
Oh gosh. I mean, I would guess that each planet has at least one moon. Does any planet just not have any moons? Yeah, they probably have moons.
Okay.
Pluto has a moon so big that they kind of go around each other, right? That's one of the things you told me about Pluto. But I don't know. I would guess they have something that's going around them that's considered a moon.
Okay.
I mean, here's the thing is I just keep thinking it's really cold out there. But it's really cold in like a lot of space, not just your proximity to the sun.
Yep.
So I'm going to stick with that it's cold.
Okay. How cold do you think?
Ooh, very cold. Very, very
Okay.
cold. Like we talked about another planet where dry ice exists on it, and that was like a planet
Yep.
that was much closer to the sun. So I'm
Do you
guessing
remember
like,
which planet that was?
gosh, was it? It was at the poles of a planet. Was it
Uh-huh.
Mars? I think
Yeah.
it was Mars. Yeah,
Mars.
okay.
Yeah.
Um, so I'm guessing it's like, yeah, like any um elements are like in a different state of matter out there. You know what I mean? Like the
Okay.
dry ice being on Mars is like things just I'm guessing it's cold enough that it's not chilly. It's like I mean, we would
Okay.
just like instantly die, but then like I'm guessing
Sure.
there's interesting elements out there. Things
Yeah.
that happen to elements.
Then do you think Uranus and Neptune are more similar in their surfaces or structures or whatever to the rocky planets like Earth or the gas giants like Jupiter and Saturn?
Well, they're gas planets, so I guess that they're more
Okay.
similar to the gas giant.
Okay. Okay.
Which then I don't understand how Santa's workshop is there exactly, but
Mm,
like,
yeah. Well,
yeah.
I can answer that one. No problem. I think to start, Cheryl, we could talk about what they look like, and then we'll kind of build from there, okay?
That sounds great.
All righty. Well, you're sort of right in the colors. Definitely blues.
Okay.
Not really purple, but maybe I might know what you're thinking about with that.
The Neptune elves have purple skin, so that might be where my brain kind of filled that in too, you know.
That definitely could be it. I could see that being it. Well, let's look at some pictures.
Yay, I love this part. Ooh, it's so pretty.
So here's Uranus, right? Sort of a light blue, almost teal, but not quite.
Yeah, getting a bit of a green. You know what is really striking to me in this is that so far the gas planets that we've looked at have had like such like a marbly, you know what I mean? Like it's not just like this looks like a matte green. Like it looks like I was about to say a marble, which is funny that I was calling the other ones marbly, but it looks like a bouncy ball, like a solid colored ball. You could turn this any direction and it would just be like, yep, there it is. So that's really different.
It is. And actually, if I go here, there is a little bit, you can see if I kind of like spin this around, you can see that there is some definition still, but not quite like what we've seen on the other gas planet giants, right?
Yeah.
So yeah, it's definitely different, which I think I'll also take a moment to share. Sometimes some astronomers will actually call Uranus and Neptune ice giants instead of gas giants. It's still sort of gas-like, but because they are so cold, like you mentioned, there is definitely, they are different from Jupiter and Saturn. There are some distinct differences.
Okay.
So here is Neptune, however.
Well, no wonder I thought purple. I would definitely say this has some purpley going on. That's so
beautiful. To me, it's
beautiful.
a deep blue, but yeah, I can see where you might get purple from it.
Wow, that's gorgeous. And there's like a green, like a bright green line in the middle of that.
Oh, yeah, that's a storm. So there's storms there, kind of like on Jupiter, sometimes, again, as big as the planet Earth, which leads pretty naturally, I think, into one of the other questions that we were talking about, which is how big are they?
I guess they're pretty big.
They're pretty big. So here is all the planets in the solar system, their sizes to scale. Their distances are not, but their sizes are to scale. So you can see
more helpful to have them so close to each other than, you know what I mean, and not have the distance
for this,
there.
Yes. Well, because technically, if you can't scale the size and the distance and have it fit in any reasonable way. because the
they would
planets
just be
are
dots,
so
right?
far apart. Yeah. Yep. In order to fit it on a screen like this, they would all be so small you couldn't really see.
Mm-hmm.
Yeah. But so as you can see, Jupiter definitely the biggest. Saturn also pretty large, especially if you don't count the rings. But if you do count the rings, that's even bigger. The inner planets, Mercury, Venus, Earth, and Mars, a lot smaller. How would you describe the sizes of Uranus and Neptune then?
Significantly bigger than the first 4 planets. And then, gosh, just me estimating, I'd say like if these were 2-dimensional, I'd say I could fit like the surface area of like 4 or 5 or 6 of them. You know what I mean? Just like flat, like it was like a paper cutout, like across that, across like Jupiter or Saturn, I would say. Wow. Okay. I have a question then. Looking at this, I feel like it's probably not a coincidence that these really small 4 planets are much closer to the sun. And then these larger ones are further away. Like, is it that the gravity of the sun has more of an impact on these smaller objects, and so we're much closer?
That is a great question. And believe it or not, that is something that my students in one of my astronomy classes were learning about today.
Are you
Literally
serious?
today in class.
That's so cool.
Yeah. So I will give you the short version because there's a whole lot more to really explain it. But it basically comes down to how the solar system formed, which it was a big nebula, which is kind of like a cloud of gas and dust in space. And as the planets are forming initially, the sun has this thing called the solar wind, which I don't remember if we've talked about that before.
Yeah, a little bit. Yeah.
Okay. It's just stuff is coming off of the sun and it can like blow things out. It can push stuff, especially if it's really, really light. The lighter something is, the easier it is to be pushed, which I think that's fairly intuitive with our everyday life. So any of the really, really light gases like hydrogen and helium, which is what most of the gas planets are primarily made of, all of those were really easily pushed out of the inner solar system. Whereas the heavier materials like iron or other metals, things that we would, silicon, things that we would think of that like would make up rocks, those things didn't get pushed as easily. And so they stayed near the center, but all the lighter stuff got pushed away out into the outer solar system where it was farther away, so it wasn't pushed as much. And so then those planets forming in the outer solar system farther away from the sun were more able to accumulate more gases because there were more of them on the outer edges.
Interesting. That makes a lot of sense. I didn't even think about that aspect of it.
Yeah.
That's really cool.
Yeah, it's of course more complicated than that, but that's the gist of it. But great job noticing the pattern. That's what scientists do. We notice patterns and then try and figure out how it happened. So way to go. So we've got the sizes, we've got the colors, and if you were to guess in here with Pluto, because you were originally comparing to Pluto, where do you think Pluto might be size-wise?
Well, it was the smallest planet when it was a planet.
Yeah.
So smaller than Mercury.
Yep. And it's actually even smaller than the moon, our moon.
Well, no wonder it's not really a planet then. That's really small.
Well,
it'll just be a dot on this thing then.
Oh yeah, it would be super tiny. But just, I mean, to throw a wrench into it, size isn't the only thing because Jupiter's largest moon, Ganymede, is larger than Mercury.
Oh, wow.
But Mercury still counts as a planet and Ganymede doesn't. So it still gets fuzzy, but yeah. One of the other things that you were talking about was like the temperatures on these planets.
Yeah.
And you were guessing that it gets colder the farther out you go, which is, yes, that is generally the way it goes. Just to give you a little bit of a reference. So the coldest temperature that they've measured out on Uranus is about -320 degrees Fahrenheit.
That's very cold.
And that is very cold. And
Yeah.
the coldest temperature that they have measured on Neptune is negative 330 degrees Fahrenheit.
Ooh, boy. Bring your
So both
jacket.
of them are very cold. Yes.
Yeah. Wow.
Yes. So both very, very cold. And just for reference, coldest temperature they've measured on Pluto, negative 375 degrees Fahrenheit.
Okay, so those have a bit of like an order or like a sequential order to them, as opposed to like when we talked about Mercury and Venus, there were some things that like didn't feel as intuitive as that because of the impact of the atmosphere, right, or lack of atmosphere on those planets.
Correct.
Okay.
Yeah, exactly. And so there's two things happening. One is the quote unquote atmospheres of these outer planets, the gas giants or ice giants, are much more similar to each other, although Pluto clearly isn't. The other thing is, as you get farther away from the sun, it's just plain. You just don't have anything to like warm you up at all, because the amount of energy you get from the sun decreases rapidly as you move far away. So it starts to kind of add up to the point where it's like, well, it's just cold now.
Yeah. So interesting.
Yeah. A couple of unique things about each planet. So Uranus, one of the things that's interesting is it actually rotates, and rotate like on an axis, right? Like the Earth rotates around once every 24 hours. Uranus's axis is actually tilted on its side, where it's pointed almost directly at the sun. So instead of rotating around, like, in a sense, perpendicular to its orbit, it's rotating around almost in the same plane as its orbit, which means like seasons are about like half of its whole year, because you're like facing the sun like the whole time if you're in the northern hemisphere. And then if you're in the southern hemisphere or vice versa, you're just in darkness that whole time. Doesn't matter that the planet rotates around. That doesn't change from day to night for you.
Oh my gosh. So much more extreme than like living in Alaska, where you hear about like really long, like 20-hour days. It's just like, well, there's just like, it's day or it's night.
Right. It's like the season, like half the year it's daytime and half the year it's nighttime, like consecutively.
Wow. So they have 2 days a year?
Basically, if you want to talk about, with sunrise and sunset, like that idea. Yeah.
Interesting.
Yeah. Well, no, one.
Oh yeah. Yeah. One day a year.
1 day a year. Yeah.
So the length of the day and the year is the same.
In that sense, for that definition of day, yes.
Yeah.
Typically, when we define day, we talk about how long it takes to rotate on an axis once. So that is not the same. But as far as practically, the way you and I would think of day is like from sunrise to sunset, back to sunrise again. Yes, it would be that. So that would be something that I think would be extra deadly on Uranus, is when you go into the night half of the year, like you are freezing and it's not warming up anytime soon.
Wow. What's the temperature difference between day and night on Uranus?
That is a good question. I don't know. Let me see if I can find it. From a quick little search, it looks like the warmest temperature observed is 116 degrees Fahrenheit.
Oh, okay. Yeah. So like nice hot day sometimes. Is it because it's facing the sun for so long that you don't get that break from it?
Yep. So even though it's really, really far away, it's able to continuously absorb that amount of solar radiation, which if you think about it, if you were to spend literally years in direct sunlight here on Earth, be a little bit warmer than 116 degrees Fahrenheit, I think.
Yeah, seriously. Yeah. So like sunrise is still going to be pretty cold there, but like about, noon would be a little bit different. That'd be so weird to be like that your planet is spinning, but you're just still facing the sun or not facing the sun.
Yeah.
That's so interesting.
Very, very different.
Yeah.
Very, very different. Now on Neptune, we got a whole nother thing going on. It's, it's rotation, more what we're used to, not a super big deal, but it has the highest winds in the solar system.
I would have thought Jupiter.
Yeah, you would think so, wouldn't you? Because Jupiter, like what we looked at, and it does
The
have really
famous
fast
storm.
winds.
Yeah.
Yep, and it's got that. But so here's the thing. So the winds can be moving at speeds of more than 1,200 miles per hour.
Oh my gosh.
Mm-hmm.
Wow.
Yeah.
That's hard to picture.
Yeah. Yeah. In context, it's in reference, there can be like 3 times stronger than Jupiter and 9 times stronger than Earth.
Wow. Oh my gosh.
So that's what makes, other than being really, really cold, that's what makes Neptune really, really dangerous, is those crazy, crazy winds.
Yeah. Oh my gosh. If you were in that, you would just die from being blown away.
Yeah, I don't know. Yeah, I don't know
Like,
how that
if you
would
don't
actually
crash
play
into
out.
anything, then do you just die from starvation?
I mean, I guess. But I mean, like,
If you
you'd just be
can't stop?
like whipping around. Like, there'd be nothing. And you'd be probably like tumbling around and all
That's
of those
true.
things.
Like,
So,
it'd be bad for your
yeah.
body. Like, you
Yeah.
might get injured even if you're not hitting things.
Maybe.
It might just like
Potentially.
mess with your system or like
Yeah.
your
I don't
organs or
know.
something. Like, it's just hard to picture what even happens because here, if winds were going that fast, you'd like hit a tree and they'd be like,
Yeah.
oh, well, you died from impact with the tree,
Yeah.
really.
Yeah.
But without any obstacles,
Yeah.
you would still die eventually from it.
Well, and again, that sort of depends on a lot of pieces, because as long as you're moving at the same speed as the winds, then it's not really going to feel like it's windy. Right?
Yeah, I don't think you'd be very comfortable still.
Well, maybe not. But
You'd just be flying.
Anyway,
Your
you would be
body would
flying.
just be flying.
You would be flying.
Oh, so if you want to experience flight, then you could
Yes.
go to Neptune.
Yes. Or you try to hit the ground and miss. That's what the Hitchhiker's Guide to the Galaxy says about how to fly.
I forgot about that. I love that. Well, when we were talking early on about the gas planets, I was saying that, like, could I walk on them? And I was saying, like, if I just like stepped off of my spacecraft, would I just keep falling through the planet? But I think on Neptune, you wouldn't fall very far. You would just
become
whoosh. Like, you would just orbit around Neptune for the rest of your life.
Sort of, except you'd be in Neptune, so you wouldn't be really orbiting. But yes, I see what you're saying. Yeah. And they do think that. Yeah. And they think that Neptune and Uranus might have rocky cores, like deep inside. But again, you would probably die before you got there anyway.
Interesting. Wow.
And now, Cheryl, it's your favorite time of the lesson. Quiz time.
Nap time or recess or lunch.
Yeah, we don't really
do
recess at my level. Sorry.
That sucks.
Or
so
nap time.
Bad. That sucks too.
Yeah. I was talking to students today actually about how I really think we should have like a science of sleeping class where we like did labs of testing what would happen if you like took a nap every day. How would that affect the rest of your day? And, wouldn't that be great?
My band director in high school let us do like a 10 to 15 minute power nap sometimes.
Oh, nice.
It was fantastic. Oh my gosh. Yeah. It was a good call, man.
Naps are great.
Yeah. That's the test, right? Naps are great.
You can't distract me. No.
I almost did, though, if you think about it.
You almost did, but you didn't. First question. What are the colors of Uranus and Neptune?
Uranus is a greeny bluey, and Neptune is a purpley bluey.
Okay, greeny bluey and purpley bluey. I think those are the official colors.
Yes. Yeah.
Okay. How big are Uranus and Neptune compared to the other planets?
Well, they are the third and fourth largest planets in our solar system.
Oh, look at
And
you.
I know I can count. It's very cool. Um, I did not sleep through that day in school. And they are definitely still gas giants compared to like us teeny tiny solid planets, which are just a fraction of the size of them, really. They're a lot smaller
Yep.
than Jupiter and Saturn, but they're still really big.
Yep. Yep. That's great. How would you die if you went to Uranus?
Well, immediately, very quickly, I would suffocate and freeze. Freeze and suffocate would happen. And if I weren't freezing or suffocating, if I had like a cool like oxygen tank situation, and could somehow like establish a life on Uranus and be like, you know what, I'm gonna make this my home, and this is where I'm gonna raise my family. Then we would eventually probably have too much sun exposure, but that would may not kill us. Like, I don't know if you die if every day was 116 degrees, if you had shade, or other things. But then that nighttime, man, that would wipe us out for sure.
Yeah. Yep. Definitely. And what is the really exciting, unique way that you could die on Neptune?
Probably of boredom, but if boredom doesn't well, here's the thing. At first, it would be the first thing would be terrifying to be in that wind. And then when you don't hit a tree or a cow or something, then it'd be like, this is kind of cool. Like, I've never been able to fly before. And then after a while, you just be like, oh, we're still doing this, huh?
Yeah.
And then like not have water to drink or food to eat or rest eventually. Like, there's like a lot of like natural causes that would actually kill you eventually while you're flying through the air.
So death by flying.
Yes, death by flying.
Okay. Last question. Which planet would you like to visit? Of the two, if you could visit one, which one would you choose to visit and why?
If I could be magically rescued when I chose, then definitely Neptune, because it would be really interesting to be in winds that fast. Like, if I wasn't going to hit something. Yeah. Although I guess we don't know. I don't know if scientists know enough about that planet to know that I wouldn't hit something, but like in my mind, it's all gas, so there's not like solid objects.
Yeah, I don't think there would be anything solid for you to hit. I don't think.
Great. Yeah, if I could just be in my little spacesuit and be dropped off there and then probably just like teleported out of there, then I would definitely choose that. Yeah.
Okay, great. Well, Cheryl, that's the solar system. That's our deadly solar system. We've made it from the beginning all the way out to the edge, sort of, at least as far as the planets go. So as the end of the unit, we also need to do a unit reflection.
That's right. This is something we do.
First unit reflection question. What were some things that you found interesting in this unit?
Oh my gosh. I mean, everything. This was so interesting, Ryan. But I think that more specifically, I knew that on most planets we would freeze and not be able to breathe. Like, I was kind of like aware of those situations. But there's a lot more variables than I thought about on these different planets. And so on top of like ways that I would die or, like things like that, it was just like interesting learning more of the differences between the planets and like what makes each one unique. Because I mean, as you know, my list wasn't very long as far as what I knew, like way shorter than other units I think we've done, where like I just have been at a loss a lot more
Mm-hmm.
for more
Mm-hmm.
information that like I haven't been able to just like have educated guesses on or be able to like kind of fill in some of the blanks. And so it was just like super interesting actually learning these details that I'm just honestly wondering, like, did my classes not cover these things? Like, I just feel like my brain was like empty, not even like, oh, I kind of remember something about this. Like, I don't know. Yeah.
I think there's a couple of factors. One is, no, I don't think your classes probably did cover all of
Mm,
these things, just because typically, like, information about planets is done in elementary school. And
yeah.
that's about it. After that, you focus on other things when you talk about the solar system, and you don't even really talk about the solar system a lot in the higher grades unless you seek it out. Like, for
Yeah.
example, I teach 2 different astronomy classes, one of which is focused on planets in the solar system. But other than that, like, people aren't getting most of that in high school. It's not standard. So I think that's probably part of it. The other piece too to remember is, in the last 20 odd years since you've been in school, more than that, depending on which grade we're looking at, right? We've learned a lot more about the solar system too. So
Mm,
some of these things that we've talked about during this unit, when you and I were in elementary school, we didn't know those things, or at
mm.
least not outside of a planetary scientist, because there also wasn't the internet to get that information out quickly.
That's a good
So,
point. Yeah.
so I think both of those factor into that.
Yeah.
Second reflection question: what were some things that you found challenging in this unit?
I mean, I think just what I said is like just these like gaping holes of information in my brain where I just it was harder to and mm, okay, I think this might also be because more of what we talked about here was about facts than about the why behind things.
Mm-hmm.
And a lot of
Mm-hmm.
other lessons we've talked about, why is something this way or how is it this way? And then
Mm-hmm.
I can use what I already know to build upon. And
Yeah.
when it comes to facts, it's like, well, either I know if Mercury has an atmosphere or I don't know this.
Mm-hmm.
There's nothing I can point to about a planet to say like, well, I bet this because of this other thing because there's not even enough to build upon in the first place. And so
Yeah.
other than like really basic things. And so it was definitely challenging to just be able to say anything that I knew. And I don't think the recall
Mm-hmm.
memory was even there because like we were saying, I don't think I was taught these things at all. And so
Yeah.
yeah, there were just a lot more things that I just had to ask you as opposed to guessing or going off of a
Mm-hmm.
little bit of memory or things like that.
I think that's really insightful to recognize the difference in the types of learning, basically, that you've been doing. Where, yeah, a lot of science, and the part of science that I like the most, is about the processes, the hows and the whys. And one of the things I like is, yeah, you can reason your way through things. Even if I
Mhm.
don't know this thing, I can make a pretty good educated guess based on these other things that I know. Whereas just the straight up facts that you just gotta either know or not, those are actually, in a lot of ways, harder because you
Yeah.
can't fill in yourself.
Yeah.
Yeah. Yeah. All right. Last reflection question. What ideas do you think you might remember or might stick with you from this unit?
Again, so much. Like I think just because and maybe part of it is like there's probably a lot of things about science that I could learn that I'd be like, "Oh, I didn't know anything about that thing," and hopefully
Mm-hmm.
I would retain a good amount of it. But this is kind of also unique in that I knew the planets existed, and I'd seen models of them, and like that was all so familiar to me that now like it's like learning about something that I already knew about, in a way, you know what I mean? And so it's just like filling in these blanks for something that was very familiar to me. And so I think a lot of that I will retain, just, because it's like those, I don't know, it was building upon something in that way. Yeah. And I think just it definitely, this isn't actually directly the question, but it definitely makes me curious to learn even more about like astronomy in our solar system, because now it's like, oh my gosh, there's so much cool stuff out there. It's not like we're the interesting planet and then there's a bunch of rocks. It's like, oh no, there's all sorts of interesting things going on out there. And so that like makes me more curious for more as well.
Yeah, which, I mean, obviously you're preaching to the choir here, because I love astronomy for all of those reasons. But yeah, like we just touched on the planets, but we barely talked about moons. And there's so many interesting things happening in moons in the solar system. And then there's comets and asteroids, which we've talked a little bit about in previous lessons, but then we didn't talk at all about the Kuiper belt or the Oort cloud or any of these other things just in our solar system alone. So I completely agree. It's all very cool and very interesting. But unfortunately, Cheryl,
wait. Ryan, you never told me if Uranus or Neptune have moons.
Oh, yes, they both do.
Okay, great. Cool. Now we can.
Sorry, they were on that screen that we saw the pictures of. It said how many moons they each had.
Oh, so did that take reading? Because I was looking at the pretty colors. So
I mean, kind of. So right now, as far as we know, Uranus has 27 moons.
Holy moly.
And Neptune has 14.
Is this just because of their mass? Is this why all these big planets have so many moons? Is because there's like more of a gravitational pull? Okay.
That's part of it. It's also, again, how they formed, and that the farther out you get, the more of the other bodies there are, other things that can fill up that space. And it's a lot of those. But yes, the mass is definitely a component to that, for sure.
Interesting. Okay, now I'm good.
Now you're good? You just had to get one more bonus question in there. Okay. Well, so sorry, Cheryl, but we are now out of time for the lesson and for the unit. So why don't you pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.